We're going to go ahead and get started. We're solving with quadratic formula today. So the only time that I would use quadratic formula is when you cannot factor, okay? And for the most part, everything we did yesterday, we could factor and solve. If you come up with like a whole number or a fraction, a nice fraction, you guys will see what I'm talking about if we have one, then you could have factored it, okay? If you come up with something with a square root left, then you know that it wasn't factorable. So that is your goal, is to only do quadratic formula when you cannot factor. So if like we look at the first one and I put it in my calculator, yell at me if somebody comes in. Y'all don't have to do this right now. I'm just showing you. I'm putting in negative 13 and I'm looking for factors of negative 11. There's negative 12 and then it's an error. So there is no factors of negative 11. You got it? You see what I'm saying? So this one is not factorable, but we can solve it using quadratic formula. So your quadratic formula is x equals negative b. So that just means change the sign of b, plus or minus a big fat square root b squared minus 4ac all over 2a. And you should have seen this before. You guys seen this before? Yeah? Okay. So math 1 and math 2 should teach it a little bit. And remember that your A's, B's, and C's come from your equation ax squared. We only want numbers in quadratic formula. The only variable that you should have is this x equals. Everything else should be filled in. Ax squared plus bx plus c. So it's with a quadratic. Only numbers, no variables after the equal mark. All right, so for the first 5, they're already set equal to 0. So they're ready to go as is. If they are not, like number 6, the first step that you need to do is get them equal to 0. So we won't do that until we get there, but your first step is to get equal to 0. And then your second step is to do your quadratic formula and then simplify. The hardest part of this is simplifying the square root. Everything else is easy. Okay, so I'm going to try to make it as easy as possible. I have not taught any of you how to do this, so it may look different than what you've learned before, okay? But I try to make it super simple. So for the first couple times, I'll write out what A, B, and C is, and then I'll stop doing that because you should be able to pick it up out of the equation. So for the first number, the number in front of n squared, if there's not a number, is always 1. So A is 1. B is your middle term, which is negative 11. And C is your last term, which is negative 13. I'm going to make that look a little bit better. Okay. I rewrite my formula. I will stop doing this step as well. And then I plug in my variables or my values. There we go. Happy Tuesday. All right, so B right now is negative 11. When we put it in our formula, all that means is change the sign of B. So a negative 11 is going to be a positive 11. So change the sign of B. Plus or minus, big fat square root. Regardless of what B is, I always put it in as a positive right here because when you square it, doesn't matter what number you square, it's always going to be positive. So I don't even try to mess it up, okay? If you guys, and I'll show you in a minute what I'm talking about. If you put a negative in here, you got to make sure you use parentheses and you got to make sure the square is to the outside. It's just too much to remember. So I just do a positive. So 11 squared minus 4 times A is 1. C is negative 13. All over 2 times A is 1. Listen carefully. Do not put in the square root, only what's underneath. So here's where I'm talking about, don't use that negative. I'm going to put in what I have right now. 11 squared minus 4 times 1 times negative 13. You can use parentheses. You can use times. It doesn't matter. It works both ways. I'm going to make it where you guys can see it. It's not going to turn down anymore. All right. So 11 squared minus 4 times 1 times negative 13 gives us 173. If you're not careful and you put in this, remember I told you it has to have parentheses around it, it's going to give you the wrong number. I'm going to fix this. It's kind of blurry. That's much better. You guys see that? So the way you would have to do it is put those parentheses so that you get the same answer. I just feel like that's too much work, so I just keep it positive. Okay, it's up to you, whatever you want to do. Just realize if you use the negative, put parentheses around it before you square it. Okay, so 173 is our number. And then 2 times 1 is 2. The next step is to see if 173 will break down. If it won't, you're as good as you're going to get here. So the way that I do it is I put it in my calculator like this because I don't know my factors of 173 and I don't expect that you would know them right off the top of your head. So this will give them to me. If you see whole numbers, the only one I see right now is 1 and 173. Clearly, we're getting 9, 8, 7. So you guys can see there's no whole numbers. So 173 is prime. This is as good as it gets. Nothing else that I can do to this problem. We will have some that break down, so don't worry. I'm going to show you all that. Okay. So on this one, A is 2. Is the term with your x squared or your b squared in this case. What is b? Negative 1. And what is c? Negative 7. All right. You guys see your formula right here. I'm just going to follow through. Change the sign of b. So b was negative 1. Now it's going to be positive 1. Plus or minus a big fat square root. Again, inside I always keep it positive. So 1 squared minus 4 times a is 2 times c is negative 7. All over 2 times 2. Only going to put in what's underneath the square root. Do not do the square root. Just what's underneath it. So 1 squared minus 4 times 2 times negative 7 gives us 57. Okay. 2 times 2 is 4. I'm going to check. My factors of 57. I already know this one. There's 19 and 3. Will that break down at all, 19 and 3? No. So this one is as good as it gets. There's nothing else you can do to it. So the only way you can do anything more to this problem is if that number under the radical breaks down. Okay. Look at your next one. What's your A? Your B? And your C. Okay. I'm going to keep that formula up right there. X equals, change the sign of B. So instead of negative 9, it's going to be positive 9. Plus or minus big fat square root. B squared, I keep mine positive, so 9 squared. Minus 4 times A is 7. C is 4. All over 2 times 7. Oh, sorry. Only put what's under the square root. So 9 squared minus 4 times 7 times 4. And we get negative 31. Now we haven't gotten a negative yet, so this one's going to be a little different. Over 2 times 7 is 14. Will 31 break down at all? No, it's a prime number. It's as good as it gets. But we cannot have a negative under here. So this is where we have imaginary numbers. And again, you guys should have understood this, like math 2, math 1. I don't think we do it in math 1. Definitely math 2, you do imaginary numbers. Do you remember what an imaginary number looks like? An I, right? Okay, so that's all we do. So anytime you see a negative like this, all you're going to do to fix it is pull that I out, and it becomes a positive 31. Now, we said 31 will not break down, so this is as good as this problem gets. Again, we cannot do anything else until that 31 breaks down, but do not have a negative square root in there. Pull out that I. All right. Number 4, A is 5, B is 1, and C is 2. Again, because it's equal to 0, don't forget we got to get it equal to 0. All of these have been, so we're good to go. X equals, change the sign of B, so -1, plus or minus big fat square root, B squared minus 4 times A times C, all over 2 times A. And again, just filling in the formula. If you've not memorized this formula, there's a couple songs to it. If you guys see Miss Hoover today, ask her to sing it for you. Seriously, it's fun. She'll be excited. Just say, Miss Jones taught us the quadratic formula today. And she'll start singing it. All right. Again, only what's underneath the radical is what we're going to put in. So 1 squared minus 4 times 5 times 2 gives us -39. And 2 times 5 is 10. Now, what we know is that 39 will break down, but I want to do it a step at a time. Let's go ahead and take out our I and make it a positive 39 over 10. Okay, so we already knew how to do that. The only other thing we need to do is break down that 39. So this is how I do it. I'll make a little side note over here. 39 is 3 and 13. Everybody good with 3 and 13? Yeah? If we have a square root, we want to have pairs. Are there any pairs in 39? So did I have 2 3s or 2 13s? Did you? No, I didn't, right? Because 13 won't break down at all. So if it will not give me pairs, this is as simple as it gets. So it's not necessarily that it breaks down, it's that it gives me pairs. So I'm hoping we get 1. I wish I would have kept the answers to this so I could go immediately to 1, but I don't have them. So, all right, I'm doing it on the fly. Look at your next one. What do you notice about this? They have a GCF of 2. You don't have to worry about the GCF in quadratic formula. It will come out on its own. I want to leave the GCF in there so you can see where it comes out. If you want to take the GCF out, remember when we're solving, it doesn't matter after that. So you can take the 2 out and ignore it. Simplify everything by 2 and use those numbers. This time I'm going to keep it in there just to show you what will happen. Okay, so you don't have to take it out. So we have A is 10, B is 6, and C is 2. All right, X equals -B, so change the sign of B, so -6. Plus or minus big fat square root. B squared minus 4 times A times C all over 2 times A. Do what's underneath. 6 squared minus 4 times 10 times 2, which is -44. Again, we're going to take it a step at a time. It is a negative. So I'm going to go ahead and take that I out. And then I told you I take that number underneath the square root and I break it down. What are factors of 44? Say it again. 11 and 4. 4 is 2 and 2 and 11. So I prime factorize it. You guys can do trees if you want. I hate the trees because I get lost in the diagonals. So I just do it straight across. So again, 4 times 11 and 4 breaks into 2 and 2. 11 will not break down. Do you see pairs? Yes. That is what I'm going to take out. I'm going to take a pair of 2's out. The 2 will go in front of the I. What I did not circle goes back under the square root, so I didn't circle an 11, so it goes underneath there. And then we have 20 on the bottom. The very last step is your triangle of numbers. The I and the square root of 11, you do not touch. It is done. Once you finish that square root, it is done, okay? That's going to be in the problem. What are all of these divisible by? Remember we said in the beginning we had a GCF of 2. So that's where it's going to come out now. So we're going to divide all these by 2. So we get -3 plus or minus. You can put the 1, but remember you do not need it. We keep the I square root of 11. 20 divided by 2 is 10. What you will see on multiple choice is -3 plus or minus I square root of 11 over 10. You don't need this 1. Remember, I is a variable, so we don't need the 1 in front of a variable. What's different about number 6? It's not equal to 0. So how do I get it equal to 0? Ooh, before what? Just move it over. Move that 10 over. If you can divide by 5 after that, take that GCF out, you can, or you can just wait till the end and it'll come out itself, okay? So we're going to move that 10 over. So we're going to subtract 10. Then we get 5r squared plus 7r minus 15 equals 0. Now, since it's equal to 0, we can do our quadratic formula, or A, B, and C. Here's your A, your B, and your C. So x equals, change the sign of B. So it'll be -7 plus or minus big fat square root B squared minus 4 times A times C all over 2 times A. We're going to clean it up. Remember, only do what's underneath the radical. Seven squared minus 4 times 5 times -15. A big, huge number, 349, and that's okay. It is a positive number, so I don't have to pull out I. So I'm just going to see if I can break down 349. Again, I don't know my factors. So I'm going to put it in my calculator and see if I see anything I can break down. Those are all decimals, so I can't break anything down there. Decimals, 1 and 349. Y'all, I'm just seeing decimals, which means that it's probably a prime number, right? Y'all understand that? And again, I don't know that until I go through the list. So don't feel bad that you have to use your calculator, because I don't know my factors of 349 and I don't expect you to do it either. If nothing breaks down, that's as good as it gets. All right. Any questions on the front page? All right, flip it over. We have 12, but we don't have to do all 12. I think we can get through a couple and understand it. So this one, same thing. I got to get it equal to 0. So I'm going to move the 7 over. It gives me 9x squared plus 7x. 19 minus 7 is 12. and then it shows you your A, B, and C. So x equals, change your sign of B, so -7 plus or minus big fat square root B squared minus 4 times A times C all over 2A. Only do what's under the square root. So 7 squared minus 4 times 9 times 12 gives me -383. And then over 2 times 9 is 18. Since it's a negative, I'm going to go ahead and pull out the I. Go ahead and pull out the I, and then I'm going to check 383. Let's see what I have. Do I see any whole numbers? 1 and 383, right? Everybody okay with that? This is as good as it gets. There's nothing that will break down. And that's okay. Sometimes you'll have huge numbers in there. Number 8, get that 10 to the other side, so we're going to add 10. We get 11x squared plus 9x plus 4 equals 0. There's your A, B, and C. X equals, change the sign of B, so -9, plus or minus big fat square root B squared minus 4 times A times C all over 2 times A. Only what's under the radical. If you put the square root sign in, it's going to mess it up. You're not going to be able to simplify. 9 squared minus 4 times 11 times 4. We get -9 plus or minus the square root of -95 over 2 times 11 is 22. We know that it's a negative, so we can take out the I. And then remember, I want to check my factors of 95. So get to the positive so you can see it. 5 and 19. Neither one of those break down anymore. There are no pairs. This is as good as it gets. Okay, there are no more pairs. That's as good as it gets. All right. Number 9, we got to move the 11, so I'm going to subtract 11. We get 6n squared minus 12n minus 24. What do you notice about all of those numbers? Yeah, so you can take that 6 out right now and use different numbers for your A, B, and C. But again, I'm going to go ahead and use them in there. And the reason I'm going to use them is so I can show you how to simplify it in the end. That's all it is. Okay. So x equals, change the sign of B, so positive 12, plus or minus big fat square root B squared minus 4 times A times C all over 2 times A. When we finish this problem, I'll go back and take the GCF out and show you how much easier it makes it, but I'm doing this for a teaching purpose, okay? So I would suggest that you take the GCF out, but if you don't, it does not hurt you, okay? It will not hurt you. So again, only what's underneath the radical, it's going to be a big number. 12 squared minus 4 times 6 times -24 gives us 720. It's a positive number, so I'm just going to go ahead and try to break it down. I don't know my factors of 720. I do, but I'm showing you, okay? Find something that you can break down. Like, I'm not going to do 2 and 360. I might could do 6 and 120, but I know that I can do 10 and 72 in my head, okay? So find something that you can do in your head. 10 is 2 and 5. 72 is 8 times 9. 8 is 3 2s. 9 is 2 3s. Anything that's pairs, we want to pull out. So this is what it's going to look like. I pulled out a 2, and a 3, and I left a 5. Okay, so I pulled out a pair of 2s, a pair of 2s, a pair of 3s, and I did not circle the 5. 2 times 2 is 4, times 3 is 12. Square root of 5 is going to replace this 720. So I get 12 plus or minus 12 square root 5 divided by 12. Check your triangle of numbers. They're all 12, so they're all divisible by 12. You have to put the first one. We have 1 square root of 5 over 1. These two do not matter. Okay, remember, anything in front of the square root don't matter. This one has to be there. So if you were doing multiple choice, the answer to this one would be 1 plus or minus square root of 5. All right. Just to show you this one, you told me in the very beginning it had a GCF of what? 6, 12, and 24 has a GCF of 6, which would leave me with n squared minus 2n minus 4, right? You can use those numbers and it makes your numbers a little bit easier. X equals negative b. You don't have to do this, just watch. B squared minus 4ac all over 2a. Inside, 2 squared minus 4 times 1 times negative 4 gives me 20. So 2 plus or minus the square root of 20 over 2. When I break down 20, it's 2, 2, and 5. So I have a pair of 2s, and I left a 5. So I get 2 plus or minus 2 square root 5 over 2. All your 2s will cancel to 1s. If you look, that's exactly what we got. You got it? Exactly what we got. So it doesn't matter. It'll all come out the same. You just have bigger numbers if you do it a different way. All right, I'm going to drop to number 11 because number 10 is exactly the same. We would just add 5 over and put it on the end. On number 12, we would add 5 over and put it on the end. But on this one, we got to get rid of 12n, put it in the correct place. Where does that term go? In the middle. So when I subtract 12n, we need to make sure that we have 4n squared. The 12n goes in the middle, so minus 12n, and then a positive 3. And here is your A, B, and C. There's no GCF, so this one should be fairly quick. So x equals, change your sign of B, so positive 12, plus or minus big fat square root of 12 squared minus 4 times 3, all over 2 times 4. Only do what's under the radical. 12 squared minus 4 times 3 gives you 96. Over 2 times 4 is 8. We need to check 96. I know that it will break down. I have 2 and 48. 4 and 24 might be easier. 6 and 16 is the one that I like. Why? Because I know that 16 is already a pair. 16 is 4 and 4. So 6 is 2 and 3, and 16 is 4 and 4. You can keep breaking that 4 and 4 down, but you already have a pair, so there's no point in doing that. So we have a pair of 4s, and we left a 2 and a 3, or we left 6, and we're going to replace that 96 right there. So we have 12 plus or minus 4 square root 6 over 8. Last step, leave that square root alone, but check out your triangle of numbers. They're all divisible by what? 4. 12 divided by 4 is 3. 4 divided by 4 is 1. Leave that square root 6. 8 divided by 4 is 2. This one is not necessary. So on a multiple choice, you'll just have the square root of 6 instead of the 1 square root of 6. So this would be your final answer. Okay. If you have any questions when you're doing your EDA assignment, let me know. It is on EDA. It is linked into your Canvas. It'll be just like yesterday. It's like 10 problems or something. But again, these will be a little bit longer, and you probably will have to show some work clearly. So it'll take you a little bit longer. Yesterday was a little bit easier. I would suggest that I don't think there's any that you can factor. I tried to make it so you had to use quadratic formula. If there is any that you can factor them, okay? So check it first and see if you can factor. Can I factor the last that adds to the middle? Can I do slide and divide? If you can't, then just do quadratic formula, okay? Any questions? All right, so those of you that are on Zoom,